All right, for all my fellow project controls pros out there, let's get right into it. This is a direct, no-fluff walkthrough on how to actually integrate Spider Project with success-driven project management. We're going to cover the exact operational steps, from creation to baselining to updating a truly dynamic, resource-driven schedule. Let's get started.
So, what's this all about? Well, this entire methodology is built to solve one of the biggest headaches in scheduling: getting away from those unreliable, manually entered duration estimates. You know, the ones that are often just educated guesses. We're shifting to a model where durations are a calculated output.
Okay, first things first. Step 1 is all about building the foundation. We have to set up the project's core architecture inside Spider Project, and it's got to be done right before any of the real magic can happen.
So you get into the software, and this is where you start. You'll define your core structures, your work breakdown structure, the WBS, your activity lists, and of course, the breakdown structures for both your resources and your costs. Then, you link it all together with your logical network using all 4 dependency types: finish to start to start, the whole shebang. Now, what's really critical here, as the slide notes, is that Spider Project supports unlimited levels. For the kind of complex capital projects we deal with, that's absolutely essential.
Right, with our structure in place, we get to the core of what makes this whole approach so different. Let's dive into how Spider Project handles activity durations, not as something you input, but as something it calculates.
This right here is the paradigm shift. The traditional way, you punch in a fixed duration. 10 days, 20 days, whatever feels right. The Spider Project approach completely inverts that. You give it the physical volume of work and the productivity of your resources, and the software calculates the duration for you. This moves scheduling from being an art of estimation to a science of calculation.
This is all powered by a concept called quantity-based scheduling. And really, it just shifts the focus. Instead of asking, how long will this take, we start asking, how much work is there, and how fast can our resources actually get it done? It's a subtle change, but it is incredibly powerful.
This slide breaks down the process perfectly. Step 1. You define the work volume. We're talking cubic meters of concrete, tons of steel, real physical quantities. Step 2, you assign the specific resources, like your crews or your heavy machinery. Step 3, you define their productivity rates. And then the software does the rest. It runs that simple calculation: duration equals volume divided by productivity.
So now that we have a solid schedule built on calculated durations, it's time to bring risk into the picture. We're going to apply success-driven project management, or SDPM, to create our project baseline.
SDPM is built on this 3-scenario framework for all of your key inputs, and I mean everything: your work volumes, your productivity rates, your costs. You define 3 estimates: optimistic, most probable, and pessimistic. It's so important that this applies to all the variables, not just duration, because that's how we build a truly comprehensive risk model from the ground up. By running simulations using these 3 scenarios, we can finally answer the one question every single project stakeholder wants to know: what is our actual statistical probability of hitting our targets?
And that brings us to the key metric: success probability. Now, this isn't some subjective guess. It's a calculated percentage, the statistical likelihood that you'll meet a specific target date or budget. This becomes your #1 data point for making informed decisions.
This S-curve is what you get as an output, based on whatever success probability you're aiming for. Let's say it's 80%. The simulation tells you exactly what management reserves, or buffers, you need for both time and cost. The key here is that these reserves aren't arbitrary. They are the calculated contingency you need to protect your targets against the risk you've defined. Once this risk-adjusted schedule with its calculated reserves gets the green light, it gets locked in. We freeze it, and it becomes the official project baseline. This is the benchmark that all future performance is going to be measured against.
Okay, our baseline is set. The project kicks off. Let's now walk through the operational process for keeping the schedule updated with actual performance data.
This is your update cycle. First, you input your actuals. And critically, we're talking actual physical volumes completed, not percent complete. Based on that hard data, the software automatically recalculates all the remaining durations using the actual productivity your teams have demonstrated on site. Then, you just rerun the risk simulation, and it generates your new current success probability.
This update cycle gives us our most powerful tool for proactive project control. It stops being about looking back at what happened, and it starts being about looking forward at our chances of success.
And this is the key output, the success probability trend chart. This chart becomes the single most important health indicator for the entire project. We use it to plot our likelihood of hitting our targets over time, and it shows us in real time whether our probability of success is going up or down.
You really have to think of this trend line as the project's heartbeat. If it starts to decline, that's your clear, data-driven early warning. It's telling you that your contingency reserves are being eaten up faster than planned and that management needs to think about corrective action before you're officially behind schedule.
And that's really the ultimate takeaway here. Traditional performance metrics, your CPI and SPI, they're all backward-looking. They tell you what's already happened. But the SDPM approach, because it's constantly recalculating future probabilities, is fundamentally forward-looking. It doesn't just analyze the past. It actively forecasts your future probability of success.